So we are going to give everyone a little bit longer to show up. So just like always, we're going to give everyone maybe about another minute or two before we really get things started. So just hold tight. We'll get things started here soon. Okay, let's go ahead and get things started here. So first off, to everyone who is coming, is joining again from the Algebra 1 class, welcome back. It's nice to see you all back here again for the start of this year. We'll be going through the geometry book in the in the fall and spring semesters here, and that's what that's kind of what we're going to be looking at here. For those of you who are new, welcome. I promise I don't bite, at least not through Zoom. But as with all that being said, if this is your first time meeting me, my name is Kitong. You guys can call me Teacher Liu, anything like that. But I will be teaching this class for the 40 or so classes that we're going to have over this next year. But yeah, so we're going to go through all the parts of the geometry book. If we do finish ahead of time, we're probably gonna find some review type stuff, maybe look at some questions that have to do with geometry, but we'll find something to do. But I expect us to take about the full time. I don't think we're gonna finish too quick. So if you guys are returning, if you guys have had me before, all of my rules are still the same. But in case this is your first time, just in case, I do want to make sure I say this once, so that everyone, gets to hear it, right? So a couple of things. First off, so the way that this class is going to work is there's going to be a lot of questions that the book introduces. So the way that this book is written is for every single chapter, for every single piece of the curriculum, it will bring a bunch of problems and it will show you how to solve those problems. And while it's solving those problems, it will teach you the material that you need to know, right? It's going to say, okay, well, to do this question, you're going to need to apply this new thing that you may have somewhat seen before, right? Or, we're going to teach you something new, and then from here, we're going to make use of it, right? Or we're going to see if there's a pattern here, and then if there is, okay, well, this is what that pattern is, right? So it's a lot of letting you learn by seeing a question, and that's what I like to see, right? And in order to have an idea of how well you guys are understanding it, I'm gonna have you guys do the questions. So I'm going to go down the list, maybe call on people one by one, and get you guys to work out the problems. And if you're struggling, if you need help, just let me know, right? I'll help you out. If you can't remember anything, if you can't remember a formula, right, I'm not going to give you a hard time. Just let me know you can't remember. I'll tell you what that formula is. And then if for any reason you don't want to answer, maybe you're just not feeling great, maybe you're sick, anything like that, right? You don't have to tell me why. Just tell me you don't want to answer. Maybe you're outside. Maybe you're out I don't know, maybe you're in the car or something, right? But point being, if there's any reason why you don't want to answer a question, just let me know that you don't want to answer one, and I won't call on you. It's that simple, right? But please let me know, right? Otherwise, I'm going to keep you in mind, right? But if you don't, right, please remind me at the start of class, right? Please let me know at the start of class that you don't want to answer, and then I'll make sure to keep that in mind for that class, right? But that's one thing that I did want to bring up, and then if you if you would much rather use the chat rather than using your mic to answer, that is okay. But the problem with that is that does tend to be a little bit slower, because it's a lot quicker to speak than it is to type, right? So if that's the case, please let me know. I'm only gonna chat or something like that, and I will try to only call on you if the question is a quick answer one, right? If it's one that requires a lot of explaining, then that's probably not a great one for you to answer, right? Because it's just going to take a lot more time. Yeah. Apart from that, if you guys have any questions, I will try to make sure to ask quite often. Like, does anyone have any questions, anything like that, right? I'll try to make sure to ask that. If I don't, and if I forget for a while, and you have a question, one thing you guys can do is there's always an option to raise your hand. So if you move your mouse over, so like probably right now in your screen, you see like a bunch of profile pictures, right? So if you move over the profile pictures, you'll see towards the bottom, there should be an option that says reactions. And under the reactions, there's one that says raise hand. What raise hand will do is it will bring your name up to the top of the list of the participants, and I'll be able to see, okay, this person has a question, or this person wants to say something, and I'll know to call on you and let you speak, right? So if you have any questions and you really want to, just let me know. You can raise your hand like that. That'll help me out a lot. And if you have a question and you want to let me know right away rather than waiting at all, one thing you can do is you can chat box it, right? So instead, just type it out into the chat. I'll read it when I have, when I get to a good stopping point, I'll read it, and I will answer it. Now, if it is, if you're trying, if you don't want everyone to see the question, if you're shy for any reason, right? Or just anything, right? You can always chat directly to just me. So in the chat box, if you open it up, there's going to be a 2, and then it should be a blue if you updated Zoom recently, but it'll say to everyone. What you could do is you can click that, and then there's going to be an option that says, send chat to specifically one person. Most likely, I'm at the top of the I'm at the top of that list. It'll say host in parentheses, not co-host, but that's going to be just me. And if you want to send just me a question, you can do that. So I'll be the only one who can read it, and I will answer your question. I will need to read out the question out loud just so everyone knows what I'm answering. But I will not, I'm not going to say who it comes from. If there's a way for me to naturally answer the question without reading out the question, I'll be able to do that as well. But if it's a pretty big, topic change, then I'll have to read it out loud. Oh, one more thing. So cameras. So I know for a lot of other Zoom classes, they do require you to turn on the cameras. And then the reason why is, just to make sure everyone's a little bit more engaged in the class or something like that, right? I'm actually the opposite. I would rather you guys turn them off. And the reason why I'd rather you all turn them off, there's a couple of reasons. Number one, if you turn it on, it adds to the recording size quite a lot. So the recording becomes a little bit more, a lot bigger of a file size to work with. It becomes harder to watch through. So that's one thing. But the main reason why is because as we go through the questions, I'm going to be screen sharing. I'm going to be screen sharing my iPad. And because of that, if you share if you share a camera, if you share a video, you're going to take up part of the screen when you're viewing, right? Because then you're going to get a pop-up that shows up, shows all the people's cameras, right? And I don't want that to happen. I want you guys to be focusing on my iPad, right? I want you guys to be focusing on the problems we're working on, focusing on what I'm writing down, focusing on the work, right? I don't want you to be looking at each other. I don't want you to be looking at yourself. I don't care about any of that, right? I want you to look at my screen. Now, the reason why I care much more about that is because, if you're looking at my screen, right, with the full size, That's how I can make sure that your attention's there, right? And just as I can see your video doesn't mean you're gonna pay any more attention, right? So I'm not gonna require you to keep your cameras on, right? I don't care if you're in your bed or anything like that. I just want you guys to be watching my screen. I just want you guys to answer when I call on you, right? Things like that. So that's what I care. That's what I care about, right? And if as long as you guys do that, we won't have any problems, right? Another thing is if you guys ever need to leave, ever show up late, I don't know, anything along those lines, right? That's perfectly fine. Don't feel like you need to apologize, right? Life happens, people will be late, things will happen, you'll have to step away, right? Things like that will happen. If any of that happens, just let me know. Hey, sorry I was late, or hey, sorry, I need to go for like 5 minutes or something like that, right? Anything like that, or I need to leave early. That's fine. I get it, right? All I ask is that you guys watch the replay. So we are going to record every single class, and that is going to stay on the Padlet for a whole week. Well, the link stays up on Padlet, but the link only stays active for 1 week, right? So once that link goes up on the Padlet, it's there for a full week. So please, 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 if you miss a class, miss a couple of minutes, miss a whole problem, right? Anything along those lines, please make sure to watch the replay. If there was a question that was really confusing, please watch the replay, listen to it a second time, see if that helps. If that still doesn't help, we actually have an office hour on Thursdays that you guys can come in, ask any questions you guys may have had, and I'll answer them there separately. And if you need more time to work on any of the problems, that's also something that will be available. But right, so if you do show up late, right, I'm not going to go back. I'm not going to restate anything that we covered earlier on in the class, right? If we spent 10 minutes talking about it the first time, right, we're going to spend another at least 5 or so minutes talking about it the second time, right? So I'm not going to make everyone go through that just because 1 or 2 people were late, right? So please, 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 right, do show up on time. If you don't, just watch the replay, and you can pick up on it from there. But yeah, so those are a couple of the main points. Lastly, I do want to discuss the Padlet really quickly. So for the Padlet, this is where we're going to be posting all of our material. So I'm going to screen share our Padlet real quick, right? So right now it's pretty bare. There's not really anything here, but what's going to go up on here is you're going to eventually, right, there's going to be all the chapters in the book as well as the solutions to the problems from homework. And then, as we go on, there's going to be 1 new column per week, and the homework as well as the recording is going to be posted under each week. And then if you guys want, once you guys finish your homework, you can also post your homework answers here. And then if I see a good amount of questions, answers posted here, I'll go ahead and take a look at them, and I'll see what kind of mistakes you guys are making. And then if I notice something quite often, I'll make sure to talk about it. I'll be like, okay, I've seen this quite a lot. This is what's going on. Don't do this, or this is a common mistake. Don't do this, right? But the way this whole homework thing is going to work is, since we are going to post the solutions themselves, right? You guys will have to check them on your own. And then if there's any questions that you still don't understand, right, feel free to come in during office hours and we can talk about them then. But yeah, so that's pretty much everything that I wanted to talk about. Any questions before we get things started, I guess? So any questions about how I want to structure this class? Any questions about how I'm going to run things? Anything along those lines? I guess one last thing is whatever name you guys put on for yourself, like in the participant list, that's what I'm going to call based off of. I know sometimes people are joining from different devices and the name's like really weird. Well, if you if you don't change that name, I'm not going to know who it is, right? But those are really just some of the things that I wanted to mention. Okay, so if there's no questions, then that means that we can go ahead and get things started for geometry. So to start us off, we need to really just talk about what exactly geometry is. So geometry, as you guys may have heard of at some point, right? Geometry is just all the different shapes that you might work with. So the whole point of geometry is we're going to learn about all the different ways that You can work with your different shapes, right? Different sizes, different things, right? All the different formulas, all the different ideas that you can work with them. That's kind of the whole point behind it. That's kind of what we're going to be working with as we go on over the course of this year. But with that in mind, what that means is we're going to work with a lot of diagrams. And with all those diagrams, we need to know exactly what we're talking about whenever we go through it, right? So the big problem here is if I just say, okay, we go from one point to another point to a third point to a fourth point, right? Where do we know? How do we know which point we're talking about? How do we know what we're going through in all this, right? So what we're going to do in geometry, the first thing we're going to do is we are going to name things. We're going to give everything a name. And just like how important it is to name people, it's the same idea behind how important it is to name objects that you're going to that we're going to talk about in geometry, right? Because if everyone went around without a name, how would you know who you're talking about if I just say, hey, you, right? How do I know which of the, for example, right, which of the 25 others here I'm looking at, right? That's that's something that's a little bit difficult to do. So our first goal here is we're just going to talk about the notation. So that's pretty much what we're going to spend most of today doing. We're going to talk about all the notation that there is. Well, not all of it, but we're going to talk about the majority of the introductory notation. We're going to talk about what these different names are, how to call them in geometry, and like how we would write it in writing. And I'll show you some examples of what they. So starting things off, what we have is a single point. So when we talk about a point, typically the way that you're going to draw this is you're going to draw like a little dot, right? And this is going to be called that point. But to be a little bit more precise, a point, it would be more accurate to think of it as like a single speck, not really a full-on dot, right? Because even dots have a little bit of a size to it, right? You can have bigger dots or smaller dots, right? A point doesn't really do that. A point is simply just a position. There's no place to it at all. Like there's no size or anything like that to it at all, right? It's just a place. One way to think about it is you can think of it as coordinates, right? So you can think of it as, I think one good example would be on a globe. You can think of it as like latitude, longitude, and altitude, right? So how far, exactly where you are in the world, right? So you can think of a point as a single position, right? And what you're going to do in this naming here is we're always going to name points with capital letters. So typically in geometry, it's the same idea as algebra. The variables that you use in algebra are going to be the most common variables, the most common point names used in geometry. So we're going to use A, B, C quite a lot. We're going to use X, Y, Z quite a lot. You are going to see a lot more of things like P, Q, and O in geometry than you would in algebra. But that's simply just because point starts with the letter P, so that's why a lot of people will do that. And then Q is the letter right after that, right? So that's why people will do like PQRS and stuff like that. But mostly whenever I'm gonna do things, I'm probably gonna write down ABC. But that's just what I'm probably gonna do. So a single point, right? We're gonna label these with capital letters like point A, right? So here we're gonna say point A, right? So and then from here, right? It's okay to just refer this as just A, like from A to, I don't know, B, if I wanted to say. We would know that when I say A, I'm talking about point A, not anything else, right? So that's kind of the first thing that we're looking at, right? Simply just a single point. One thing that is a little bit important is that a point has 0 dimensions. What dimensions refers to is it refers to a direction in which you can measure. You can think of it that way, right? So if it has 0 dimensions, what that means is that there's 0 directions that you can measure for a single point. And that's, that fits in with the definition that I gave you, right? It's just a position. There's no size at all to it, right? So you cannot measure it at all. So a single point, just a single position, a single location, nothing else. Now, what about if we start putting a point and another point together? So what if we want to go from point A to point B, right? So point A to point B, if we just look at the distance between these two, if we just look at, the direct path between these two, that is what is called a line segment. Now, the reason why this is called a line segment is because a line segment has two endpoints, and it has a clear start and an end. Now, which one is the start and which one is the end doesn't matter, right? It's the same exact line segment either way. It doesn't matter if I start from A, go to B. It doesn't matter if I start from B, go to A. It's the same exact line segment. In fact, we consider line segments to be equal as long as they have the same length. We don't care about what direction they are pointed in as long as they, are the same distance, right? So a line segment would be something that we could consider one-dimensional because you can measure the distance of it in a single dimension, in a single direction, right? And that is this direction. We can measure it in that direction. Now, if we had another point, say, for example, point C over here, and we knew that, that the distances between A and B and the distance between B and C was the same, what we'd be able to say is we would be able to say that these two segments are congruent. These two segments are equal. And what we would do to mark that in this diagram is we would use something called a tick mark. Now, typically tick marks are going to be something like this for measuring distance for a line segment. So it's just kind of a little bit of like a tally through the line segment. If there's different size ones, so for example, if there was if there's another point right here, let's call this point M. So if point M is the midpoint of this line segment, what that means is it's right in the middle, which would mean that AM and MB should be the same distance because it's a midpoint, right? It would split it into two equal parts. So then what we would be able to say is we'd be able to say, okay, AM is congruent to MB. And if there's another point, let's say over here, that's also equal to CB, right? Well, if we use another single tick mark, right, it would be a little bit confusing, right? How do we know which ones we're looking at? How do we know which ones are paired with which ones, right? What I will do, because we have different colors, is I will typically use, just different color ones. So it's a little quick to see, oh, yellow pairs with yellow, red pairs with red, right? But what the book will do, because the book is in black and white, is the book will use different numbers of tick marks. So instead of using, just one, it'll use two tallies here. Typically, you'll see anywhere from 1 to 4 tick marks. But anything more than that, and it starts to get a little bit difficult to read, right? Would you want to look through like 5 different tick marks, 6 different tick marks? That's not great to look at, right? So typically in a diagram, you're only going to see anywhere from 1 to 4. But that's just because of constraints on readability, really. Okay. Any questions over what I have here? So when we talk about a line segment, we're going to label it with endpoints, right? So if I wanted to talk about the distance, the line segment from point A to point B, I'm just going to call it segment AB or line segment AB, right? And the way that we're going to write that in in print, I guess, you could say line segment AB, but there's a much faster way to do it with a little bit of notation. And that is to write out AB with a small little line segment on top of it. That represents line segment AB. So this thing right here refers to the idea of this line segment right here, from A to B. It doesn't matter if I write AB, it doesn't matter if I write BA, it's the same distance, right? We said as long as it's the same distance, it's equal. So AB, BA, same thing. Any questions here?
I have a question. So
yeah.
It's like, why are the longer lines in the middle of the longer lines has like shorter lines?
Are you mean like this one here? These things here?
Yeah.
Yeah, so that was, remember from earlier, right? We said that these were tick marks, right? Tick marks represented which two line segments had the same length, right? So in this case, I never wrote down a name for this point, right? So for these two longer line segments, right, the little kind of ticks between them, right? They're the two yellow lines here. the two, right? That just means that these two guys are the same distance. They're the same length. So the length from A to D is the same as the length from B to C. That's what that means.
Oh, so it's like if D is with C and there is like an M in the middle and then we cut it with a little lines, we know that it's the same length with one other if there's another.
So like if I made another point here and I said, okay, D here, right, this and that, right, that would mean that this length here would be the same as this length here. Yeah, that's what that would refer to.
Oh, I get it.
Like, for example, maybe this left side, right, this is like, maybe 2 inches and this would also be 2 inches, right? But that's the general idea here. That's what that little tally thing means, right? It just means that these two lengths are the same length. That's what that refers to. That's a tick mark, right? So if you see anything like that, that's what that means, right? It just refers to the information. Okay, these two distances are the same. But yeah, that's what. Okay. So let's kind of simplify this a little bit. So let's go back down to just A, B here. So what if you wanted to keep going, right? So what if you didn't want to stop? So in geometry, there is something where if you continue past B, this is what's called a ray. So a ray is kind of like a line segment, except it continues on infinitely in one direction. In this case, this is called ray AB. So AB here is considered a ray. And what you're going to do is you're going to draw an arrow to represent that it goes on infinitely in that direction. So from A towards B, but going on infinitely past B, right? So that is what this ray is here. Now, A is the starting point, and B is the direction. So the starting point is also called an origin. So A is, it could be considered an origin here. Now, it's very important that for a ray, you don't do the same thing that we do for a line segment, right? For a line segment, we said it doesn't matter if you start from A or if you start from B, right? For a ray, it does matter which one you start at, and it does matter which one I write first, right? Because you'll notice here, right, the arrow is on the B side, right? And that means that I'm going on infinitely in that direction. The arrow is not on the A side for a good reason, because if the arrow is on the A side, right, I'm going on infinitely in the A direction, but I am starting from the A direction instead. So that's why it's important that you do that, right? If I wrote BA instead, right, that would be this ray instead. It would go on into the left side rather than to the right side here. So that's something that you do need to be a little bit careful of. So a ray is this. We're not going to work with rays very much. You might see you might see a ray here and there, but we're not gonna worry about a ray too much, because at the end of the day, what works for what's called a line is going to work for a ray as well, pretty much. But what is a line? So a line seems like we've just taken off the word segment from line segment, right? But what a line is it's kind of like two rays put together. It goes on infinitely in both directions. So in order to represent this, we're going to call this line AB, and then for the notation as well, you probably guessed it, you're just going to add on an arrow into both ends here. And once again, now since we go on infinitely in both directions, it doesn't matter which one we list first. Line AB, line BA, both of these are going to be the same thing. However, for lines, there's also another way to write this. You can also notate lines. You can also name lines with a lowercase letter. So for example, maybe like line L, line J, line K. But what you'll notice is that when we do this, typically that letter is going to be in some sort of italicized font. So maybe like K, like K or something, right? But the idea is like, if you ever see anything like that, anything like maybe like J, right? Idea here, if we write it in italicized font, that's what we recognize as a line, lowercase italicized. It's a little difficult to italicize a letter in in handwriting. So typically what I will do is I'll just write it in cursive. My cursive is not great. It's been probably like, I don't know, anywhere around like 15 years by now for how long it's been since I learned cursive.
I can't read cursive.
It's okay. It's okay. If you can't read cursive, I'll make sure to say the names every time as well. And overall, it should be pretty clear. Okay, this is a J. But as long as I say the name for you at least once or twice, I think it should be okay. And if you still can't read it, it's okay. Just ask me, and we'll be fine. But yeah. So that's kind of the idea here. You're gonna see a lot of well, you're not gonna see this too much. You're gonna see a lot more of just these capital letters here. I won't usually have to name things. I won't usually have to draw things. Usually we're just going to use the drawings from the book, and those won't be in cursive. They're going to be in italics. So just a little slanted. That's all. Okay. Any questions before we continue on into some other definition? So these are some of the early on kind of figures, early on kind of definitions here. There's a couple more that we do need to talk about. These definitions, however, you're not going to use for a while. So once we define what these are, we're going to come back to these at a much later point. So if you have a single line and you have more than, if you have 3 points that are all on this line, right? So for example, A, B, and C. You could name this line a lot of different ways, right? You could name this line AB, line BA, line BC, AC, right? Any of that could work. But if you ever have 3 or more points all on this same line, this is what's called collinear. It simply just means that they're all on the same line. So co meaning, together in a sense. Linear, line, right? It just means that they're all on the same together.
Guess what? I play chess. There is a tactic called collinear moves in chess.
Yes, thanks. But sorry. So let's try to keep things like that to a minimum. If everyone does that, we're not going to be able to get through the material that we want to get through, right? So please, right? Comments like that. If you want to just add on something like that, you can just do that in the chat, all right? Okay. And then if you have 3 or more lines that all go through the same point, so kind of the opposite direction, right? If you have 3 or more lines that do that, that's what we call concurrent. So if you have 3 lines that all cross through this one point here, that one point in the middle is what we call concurrent. These ideas are gonna, they're gonna come up much later on. For now, we're not gonna worry about this too much. So we've been talking about a lot of one-dimensional things so far, right? A lot of lines, segments, rays, right? These are all one-dimensional. But once we move on into 2 dimensions, that's going to introduce us into a plane. So how do we know what we're working with is a plane? A plane, kind of like a line, goes on infinitely in all the directions it's allowed to go on infinitely in. But for a plane, this is what's called a 2-dimensional figure. So in order to have 2 dimensions, you have to be able to measure distances in 2 directions. Now, when I say 2 directions, I don't just mean, any 2 directions, right? I can't mean like, oh, okay, 1 direction here, 1 direction here, 2 dimensions. Well, that's the same, same 1 direction, right? It's just positive or negative. But apart from that idea, even if I said, okay, this is my 1 dimension, what about my 2nd dimension this way? Well, in order to be a new dimension, let's kind of editing our definition a little bit. We're going to require that any new dimensions are perpendicular to previous ones. Maybe this perpendicular word is one that you guys aren't familiar with yet. We are going to learn about it, but it just means that it must create a 90-degree angle. Again, if that doesn't mean anything to you yet, don't worry. We will talk about it in the coming chapters. But what that means is you can only do things like horizontal/vertical. That's what's going to be plane. And then for a 3rd dimension, you can consider going inside versus outside. Now, for a plane, I think one easy way to think about this is think about your monitor screen, right? That's going to be a 2-dimensional flat surface, right? Unless you have a curved monitor, in which case wow, I guess. But think about, maybe like a sheet of paper or, my iPad screen or anything like that, right? But think about this two-dimensional surface. If this two-dimensional surface went on infinitely, right? So think about making that sheet of paper bigger and bigger and bigger and, just infinitely big, right? Yeah, you kill a lot of trees for that, right? But this plane that extends on infinitely in every single direction, that's going to be our two-dimensional surface that we get to work on. We're going to talk a lot more about this starting in chapter 3 or so. Well, really, we're going to talk a lot about this even in chapter 2. But this is something that we're going to come back to at a later point for planes. So this is something that we're gonna talk more about as we go on. However, much later on in this book, right? So this book has a total of like 19 chapters. Starting in chapter 14, we're actually going to start introducing a third dimension. So like I showed earlier, that third dimension is going to be something along the lines of going inside and out as well, right? So going like here and then like that, right? That's our three-dimensional space. And three-dimensional space, the most easy way to think about this is just think about anything that you're able to see, right? Anything that you see is going to be 3 dimensions. You can measure a length, width, and height. And no matter what, any of these directions is 90 degrees with the other one. But that's something that we're going to talk much more later on in this book. So chapter 14, in the last quarter of this book, that's when we finally introduce this topic. All right. I know I've done a lot of speaking. Any questions over any of these definitions? Any questions over how we want to address anything here, anything like that? Any questions over any of the notations? All right.
Is there a 4th dimension?
As for extra dimensions, that's something that is heavily debated on. It's something that is much more. It's outside of the scope of what you're going to learn in geometry. It's nothing for mathematicians to work with. That's something that if you're in science, that's something that you're going to work with. Yeah, it's like physics type stuff, right? To directly answer you, one way to think about it is you think about a 4th dimension as like maybe time, another dimension as maybe like smell. But the idea here is anything else that you could measure could be considered a different dimension. But that's something that's we're not going to worry about in math. It's nothing that we have to care about. Okay, so with that being said, let's take a look at our first couple problems. So our first section here that has problems, we're talking about circles. Well, I've kind of given it away a little bit. Let's take a look here. So problems 1.1 and 1.2. Problem number 1.1. Let's hear from Jaden.
Mark a point on a piece of paper and label it O. Use a ruler to find points on your paper that are 1 inch away from point O. You draw all of these points. What figure would you create?
Sorry, if you draw all these points.
Oh.
So all of the points that are 1 inch away, that's going to look like, all these points here, right?
That will make a circle.
Yeah, so this is a circle. What's the definition of a circle? Do you know?
The definition of a circle? I don't know. So,
directly speaking, the definition of a circle is a collection of points that are equal distance away from a single point. And in this point, that single point is going to be the center of the circle, right? So that point O in the center, that is going to be the point at which everything in this circle is equal distance away from, right? So the distance from here to here, that's this 1 inch, right? Here to here, that's 1 inch. Here to here, that's 1 inch. All of these are 1 inch distances. So now the question is, okay, well, if that is 1 inch, well, what is that distance also considered? What is that called? Are you familiar with
called the
radius.
Okay, well, yes, it is called the radius, and I think I didn't say this earlier, but please, if I've called on someone, just let them answer through the question, right? They won't answer your question, so please don't answer theirs, right? If they do struggle, it's okay. I will take care of it. If I think they're taking a while, I'll speed things up, right? But that's for me to help them out, not for you guys. Okay. But yeah, so this is called the radius, right? The distance from the center to any point on that circle, that distance is considered your radius. The diameter is actually going to be the distance from one end of the circle to the opposite one, right? So it's 2 radii put together. But that's what your diameter is. All right, thanks, Jaden. That's what we have here, right? So just working through the definition of a circle, right? The center of the circle, the radius of the circle, right? These ideas. We're going to come back to it. This is something that's we won't really touch on for a while, right? This is something that we're going to come back to much later on. Well, I say that we're gonna come back to this in chapter 2 briefly, but then after we talk about this in chapter 2, the next time we talk about circles is going to be all the way in chapter 11. So it's going to be another, probably next year before, the next semester before we bring circles back. Okay, problem 1.2. So we've been told, okay, this is a circle. Now we have a couple questions that we want to answer about them. Joshua. Joshua, going once, going twice. Okay. How about Jonathan then? Jonathan? No? Okay. All right, Kevin, this one's yours.
The figure shown at the right is called a circle. A, is it possible to draw a line that does not hit the circle in any points? B, is it possible to draw a line that hits the circle in exactly 1 point? C, 2 points. D, 3 or more points.
So for future reference, when we do see questions with multiple pieces like this one, answer them piece by piece, right? So read part A, answer part A, and then read part B, answer part B, so on and so forth, right? But it's okay. This is the first time, right? So what do we have here for part
A? So it's asking if you can draw a line that doesn't hit the circle in any points. So like drawing a line through the circle, but it doesn't like hit anything, which I don't think is.
So the question never says that it has to go through the circle. It just says, is it possible to draw a line that doesn't hit it at all?
Oh, yeah, you could just like draw a line that is just like right under it.
So something like that?
Yeah, you could do that.
And then that would never touch the circle, right? So yeah, that part A is true. It is possible. How about part B then?
Is it possible to draw a line that hits the circle in exactly 1 point?
Mm-hmm.
Yes, if you like draw it, like, wait, actually, I don't think it's possible because like the circle, all the points, like you see the line, but like they're all really tiny points that like connect to each other. So I don't think it's really possible.
So this one actually is possible. It turns out you just have to be very careful. It turns out that if you draw a line on top of this, like 1 point on the circle, and just barely graze it, right? It is possible to get it so that it only hits 1 point. Now, the way that I've drawn this, the way that any human would draw this wouldn't be possible, right? You'd always probably at least get a couple extra points on there. But geometrically speaking, it is possible for you to do this. It is very possible that you would just only get a single nick of that circle, right? Just a single tiny bit. But yeah, it is possible to hit exactly 1 point. This is something that you'll learn later on, but this is what is called a tangent line. When it only touches a single point of that circle, that's what it's called. Let me write that a little bit bigger. Tangent line. Okay. And part C, what about 2 points? Is that possible?
Yeah, it's possible. If like geometrically speaking, it's possible.
You just go straight through, right? Straight through, that's going to be 2 points. This is typically what's called a secant. If you go straight through, it's called a secant. Secant like that. If you only do, from the first part to the second part, that's called a chord, right? So only within a circle. Well, also on top of the circle, I guess, right? But only from one part of the circle to another part, you don't take the part outside, right? It wouldn't be called a line anymore because it's a line segment. That's what a chord is. And then if that chord also went through the center of the circle, that would be a diameter. But that's what we see here. And then lastly, what about 3 or more points? Is that possible?
I don't think it's, wait, I'm not sure.
Yeah, this one's not possible, right? In order to get another third point, right, you'd have to like somehow curve back in, but at that point, you're not a circle anymore, right? So
yeah, it's
no,
not a line.
This one's a no, right? So yes, 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 no, in that order. One last thing here that I do want to bring up. So if we talk about a distance around, around the circle instead, so for example, like this, that's what's considered an arc. And then the arc is a shorter distance around 2 points on a circle. So for example, if I'm looking at this point here to this point here, the minor arc is this shorter distance. That's what we typically refer to. But if you are, trying to go the long way around on purpose, that's what's considered a major arc, right? So this would be the major arc, the long way around the circle. But that's what we see here. So if I called this point, point A, this point, point B, this point over here, point C, minor arc AB would be this, major arc would be ACB, right? So you'd use 3 points to tell you, okay, we're going the long way around. Otherwise, you default to the short way. Any questions over any of these names, I guess? Any questions over anything here? Sure, Kevin, do you have any questions?
Yeah, for like the long arc, would it also be called like a something? I forgot the name already.
Does he mean collinear?
Yeah, collinear. Would it be called that?
Well, that wouldn't be a line, right? A line is straight, right? So one thing about a line is it has to be a straight, from one direction to another, right? But since this is curved, right, we would not consider this a line in the first place. So that's why it's not collinear.
Thanks.
Yeah. Sean?
Like, if you like
You want me to come back to you once you have it ready?
yeah, okay.
Okay. So if you think of if you think of how to word your question, just go ahead and put it in the chat box, and then I'll read it and answer it once you have it there. Any other questions? Okay. If not, then that moves us on into the next section. So section 1.4 is actually a section for constructions. Constructions is probably like the one thing in this class that we're going to consistently skip over. And the reason for that is because constructions are very difficult for us to do. On like in this class. And the reason why is because in order to do constructions, there's 2 things that you need. First off, a straight edge, second off, a compass, or a way to make circles. The problem with that is I can't show you the compass that I'm using. I also cannot show you the straight line that I'm using. And also, if I do use those, it's a little difficult to draw. I'm also not very great at drawing, free-handedly using a compass and whatnot, right? So we're going to skip over most of these, and most of the time, constructions are something that you won't really learn about in geometry anyways. But there are some important things that you are going to need to know. For example, in constructions, one of the things that you're going to do is you're going to learn, okay, if you have a point, you can draw a line through that point. If you have 2 points, you can connect those 2 points to create a line, right? 2 points is a line. So there are some important ideas from these sections, but the actual drawing and things like that, we are going to completely skip. So for these ideas that are brought up in the constructions, I would ask that you guys just read through that on your own. But we will bring this up when we need it. Like, so if there is an idea that is important, I'll bring it up. I'll say, okay, this is something that maybe you guys should have learned during a construction section, like understanding that 2 points is a line, right? So any 2 points defines a line. So if you ever have 2 points, there's only one line that goes through both. If you have a line and you have a third point, there's exactly one line that's parallel to that one. But exactly what it means by parallel, that's something that we'll learn about later on. But things like that, that's something that you can learn about in constructions. That's kind of the big thing I want to talk about here. We are going to skip through this simply because it's just not really possible for us to show. If you make a line that goes between a point on a circle and the center of the circle, which way is major and which way is minor? So are you referring to a circle and then like saying, you know, exactly half and half? Is that right? Is that what you're saying? Like, so exactly half here, right? Saying which way is major, which way is minor? Is that your question? Okay. It doesn't matter. They're the same, right? It doesn't matter which one's major, which one's minor. They're both considered a semicircle, which is exactly half. So I think the argument here is that I don't think you would say like which one you're talking. You would not use the words major and minor here. I don't think so. Major and minor only refers to like exactly when one of them is like bigger, one of them is smaller. So if it's exactly half, I just, you know, I would not use those words. But that's
you can only use the words major and minor when the two lines and distances are different.
Yeah, basically. Okay. Okay, and that leads us to another piece of chapter 1. So the final portion of chapter 1 is what is called the burden of proof. So the burden of proof refers to the following idea. So if I ever ask you, and I am going to ask you in this class a lot of times to prove something or to tell me whether or not something is true. So the burden of proof simply refers to what you need to do to be able to make a claim. So if you're trying to prove that something is true, what you need to do in mathematics is you need to show us, right? You need to be able to show that it is true no matter what the circumstances are. For every single situation, it is true. You cannot give me a single example, right? So if I ask you, you know, if I ask you, hey, you know, prove the Pythagorean theorem, right? You cannot give me a single right triangle. And for this one right triangle, the Pythagorean theorem works, right? That's just an example here. If you don't know what the Pythagorean theorem is, don't worry. We will learn about that later on in this book. But the idea here is, you know, if you're trying to prove something is true, you cannot give me a single example. Say, hey, this example worked. It must work in every single case, right? Like if, you know, same idea for it's kind of also in the real world, right? If I ask you to prove to me, you know, everyone can go to college, right? And you say, hey, you know, I went to college, everyone can go. It doesn't work that way, right? Just because it works for one situation, just because it works for one person, one thing, right? One figure does not mean it works for everyone, right? So that's one important detail from the burden of proof. But that's only when you're trying to prove things are true. You need to show it is true in every situation. If you're trying to say something is false, you only need one example of when it is false. So if I was trying to, you know, prove that the statement, you know, everyone can go to college, if I was trying to prove that that was false, I just have to come up with one single example of where someone was not able to go to college. And I'd be able to, you know, I'd be able to show you, okay, well, that statement's false. Right? So if you're trying to prove something is true, you need to be able to show it is true in every situation. If you're trying to prove something is false, you only need a single example of when it is false. So as we go through the questions in this book, you're going to see a lot of questions that say, you know, is this true? You know, is this statement true or false? Well, if you've decided, hey, I want to try proving that this is false, you just need to give me a single example of when it fails to work. That's all you have to do. However, even in geometry, there are a couple things that are impossible to prove. For example, the following. These are what are called axioms or postulates. And the reason why they're so important is because there's not really a way to prove that these are true. In fact, they seem very simple, right? Number one, any 2 points can be connected by a straight line segment. It seems like this is really simple, right? Oh, line segment just is 2 points. So from point A to point B, that's a line segment. That is the line segment that connects them. Well, that's not exactly a proof, right? Because that only shows point A to point B. What about 2 other points? You could say that, for any situation, I could give you that I could tell you that example works. But there's no way to prove that it works for all of the examples at the same time, which is why that I cannot say that this is true. I cannot or at least I cannot prove that this is true, because I cannot prove it for all the situations at the same time. So that's why I cannot prove this thing, right? And any line segment can be extended forever in both directions, forming a line. Well, I can show it for a single one. I can say, okay, for this one, I just add on the arrows, boom, it's a line now, right? But how do I show that it's true for every single line segment? There's not a way for me to do that. So that's why for these examples, it's impossible to actually prove that this is true. But we are going to use this. And these examples, right, sometimes you just have to accept it. For anything that you cannot prove, we are not going to ask you, if it's true or not. For anything that you cannot prove, you will not be asked to prove this, because it's not possible to prove. So what you are going to be asked, though, is that you remember these ideas, you remember them, you remember the rules here, but it is not going to ever be asked that you prove them. We just need to remember that it's one of the postulates. So axiom or postulate. That's what this refers to. It's just something that you cannot prove is true. You simply just need to accept. These 5 are examples here. I already said the first 2. The third one is given any line segment, we can draw a circle with the segment as a radius and one of the segment's endpoints as the center. All right angles are congruent is number 4, and number 5 is any straight line and another point not on a line. There's exactly one straight line that never meets the first one. That refers to parallel lines, and that's something that we're going to learn more of in chapter 2. But these ideas here, right? These ideas are ones that you guys will want to remember. But for the things that you guys will need to prove, the way that you're going to need to prove it is you need to go step by step, right? So any statement that you make, you need to use a justification for it, right? So if I'm trying to prove something later on in mathematics, we're going to see more better examples of this later on, right? But if you're trying to prove something in geometry, what you need to do is you need to, state a conclusion and state a reasoning, state a justification, right? So the justification needs to tell you, okay, this is the reason why I can say what I said on the left, right? And then, step by step, go from one conclusion to another, go from one conclusion to another until you reach what you are trying to find, right? So in the example of the Pythagorean theorem, right, the final thing that you're going to say is something like, oh, a squared plus b squared equals c squared, and that's the final step, right? But that's just an example of like what you would do. And then that would be able to prove, this is true for every single situation. And then that would be what's called a theorem. So if you are able to prove something is true in every single situation, and you're able to come up with a step-by-step proof, that is what's called a theorem. And we're going to learn a lot of these in the course of this book. Now, over the course of this book, so over the course of the next, the following chapters as we move through this, we're going to learn a lot of different things. We're going to learn a lot of different, a lot of different definitions, a lot of different situations. We're going to learn a lot of those things, right? So what we're going to do is, so one of these things that we're going to learn, just as an example, right? You're going to learn that if you have 2 angles like this on opposite sides of the same point, you're going to learn that these 2 angles are congruent. Now, I know I'm getting ahead of myself a little bit, right? But the idea here is what I want you guys to do is, as we go through this, if it might help you, keep track of all of these things that we learned. And when you do, right, keep track of, what it's called. So what is it called? So this is called vertical angles. What do I need? So in this case, a single point, opposite angles of that point, right? And then what does it mean? In this case, those angles are congruent, right? So what is it called? What do I need to be able to use this? And what does it mean? And if you keep track of all that information, right, that's going to really help you out as we move through this book, because those you saw earlier, right, the justification and the reasoning. What do I need? What do I conclude? That conclude is the part that I said, right? What does it mean, right? What did this mean again? These two angles were congruent. That's the conclusion from earlier. The justification is, what is it called? Why is this true? Why do I know these guys are congruent? Because these are vertical angles. And then the condition to be able to use the vertical angles, that is the what do I need portion of it, right? So these three things, right? What is it called? What does it need? What do I get from it? Or what do I conclude? What does it mean? These ideas, right? These three ideas are going to be important for everything that we learn starting from chapter 2. So with that, starting next week, we're going to move on into chapter 2. We're going to move on, talk about angles. And we're going to see what our first kind of tools in our toolbox are for all the things that we're going to learn later on in geometry. So with that, homework for this week is just going to be everything from chapter 1. There's not really that many, proofs or anything, or any calculations, nothing like that so far. We're just going to be looking at a lot of different naming type things here. But with that, if you guys have any questions, feel free to stick around. Otherwise, that's going to be it here for today, and I'll see you all next week.
Thank you.
Oh,
Bye.
Thank you. Bye. 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 Bye.
Thank you.